Minimum spanning tree. What is a minimum spanning tree? A minimum spanning tree is a subset of the edges of a connected edge-weighted graph that connects all the vertices together without any cycles and with the minimum possible total edge weight. It is a way of finding the most economical way to connect a set of vertices. Creating minimum spanning tree using Kruskal algorithm. Here you can see the steps involved in Kruskal algorithm to generate a minimum spanning tree. In step 1, sort all edges in increasing order of their edge weights. In step 2, pick the smallest edge. Step 3, check if the new edge creates a cycle or loop in a spanning tree. In the step 4, if it does not form the cycle, then include that edge in minimum spanning tree. Otherwise, discard it. The final step, repeat from step 2 until it includes modulus of vertex V minus 1 edges in MST. Using the steps mentioned here, you can generate a minimum spanning tree structure. So now have a look at an example to understand this process better. The graph G of V, E contains 6 vertices and 12 edges, and you will create a minimum spanning tree T of V, E for graph G of V, E such that the number of vertices in T will be 6 and edges will be 5 of 6 minus 1. If you observe this graph, you will find two looping edges connecting the same node to itself again. And you know that the tree structure can never include a loop or parallel edge. Hence, primarily, you will need to remove these edges from the graph structure. The graph shows that removing parallel edges or loops from the graph. The next step is arranging all edges in a sorted list by their edge weights that is shown in this table. After this step, you will include edges in the MS tree such that the included edge would not form a cycle in tree structure. The first edge that you will pick is edge EF as it has a minimum edge weight that is 2. Now add edge FD to the spanning tree. Then add edge BC and edge CF to the spanning tree as it does not generate any loop. The next up is edge CD. This edge generates the loop in your tree structure. Thus, you will discard this edge. Here, edge CD should be discarded as it creates loop. That is shown in this graph. Following edge CD, you have edge BF. This edge also creates the loop. Hence, you will discard it. So in this graph, the edge BF should be discarded. Next up is edge BD. This edge also formulates a loop. So you will discard it as well. In this graph, edge BD should be discarded. Next on, your sorted list is edge AB. This edge does not generate any cycle. So you need not include it in the MST structure. By including this node, it will include 5 edges in the MST. So you don't have to traverse any further in the sorted list. The final structure of your MST is represented here. The overall summation of all the edge weights in MST is T of V, E is equal to 17, which is the least possible edge weight for any possible spanning tree structure for this particular graph. Thank you.